You are most welcome once again to this episode of Academic Research Writing. My name is Alan, and I'm going to be your host. So today we are continuing with our series of data analysis, and we are going to be talking about correlation analysis. Now, correlation analysis is one of the most important techniques that you might be needing to do in your academic research paper. So, what exactly is correlation? Now, in statistics or in research, we say that correlation analysis is a statistical technique which helps us to measure the strength and the direction of a relationship between two continuous variables. Okay, so we just need those two things. We need to understand the direction and the strength of the relationship that we think exists between two variables. Now, basically, correlation helps researchers to understand whether and how strongly variables are related without implying causation. So, what we are saying is simple. If we have two variables, are they related? Is there an association between them? Can we say that, for example, if you work hard, you're going to become wealthy? Is there an association between working hard and becoming wealthy? So that is what we are going to be looking at. And we are going to be putting it in a perspective of academic research, and we see how you can put it in your own research paper. Now, the purpose of the test is simple. One is to determine whether a relationship actually exists between the two variables, because it is very possible that there are two variables which are completely unrelated. We can also find that they are related, but if they are related, how strong are they related? And that is purpose number two, to measure the strength and the direction of the relationship. And that is the most important purpose of correlation analysis. And lastly, it can help us to make predictions. For instance, two variables are highly correlated. Maybe we could say one can be used to estimate the other. So that is what we are calling correlation. Now, for us to understand the aspect of direction and strength, we can use the concept of a number line. A number line is this line that we used to draw in primary school, which we just draw a line and then we put 0 in the middle. We put +1 on the right and we put -1 on the left. Now, if you look at this number line, it is going to help us get something that we call the correlation coefficient. So the correlation coefficient is also like the correlation value. In other words, the strength of the relationship. So we are going to go and do our correlation analysis in our softwares or everything, and we shall end up with a value. But the value that we are going to get is a value which is between -1 and +1. So the highest value of correlation analysis is 1, and the lowest value is 0. Okay. So when we see that the value is 0 at this point, it means that there is no correlation. There is no correlation whatsoever. The variables are not related at all, completely unrelated. That is what 0.00 means when you calculate correlation and get it. There is no relationship. What if you get 1, +1? If you get +1, it is going to mean that there is a perfect relationship that exists. And a perfect relationship means as one value increases, as one variable increases, the other variable also increases. For example, if we say that studying hard is associated with better performance in your exam. So we can see that the more hours that you put into studying, then it could be associated with the performance, maybe better performance, okay? So if we get the chi-square, if we get the correlation coefficient of +1, okay, then it means that it is a perfect, for example, for every hour that you study, then it can result into maybe 10 marks that you will get into in your academic, in your examination paper. Okay, so that is what they call +1. Now, the highest correlation coefficient is +1, with the lowest being 0. Okay, but it is also true that the highest correlation is -1 with the lowest of 0. Now, +1 and -1 are there to just show us the direction. So for instance, you get a correlation coefficient of 0.9. So it means it is around here. So that is a strong relationship, okay? If you get a correlation coefficient of 0.1 or 0.05, so it means it is around here. That is a weak relationship. So if the value that you are getting is closer to 0, then the relationship is weak. If it is closer to +1, then the relationship is strong. It is also strong if the value is closer to -1. So then why do we have negative and positive? So negative and positive is going to help us understand the direction. So with direction, it means that if the correlation value or the correlation coefficient is +1, it means that as variable 1 increases, the other variable also increases. It also means that as one variable increases, the other variable, so if one variable decreases, even the other one decreases. What positive means is that the variables move in the same direction. If it is increasing, they increase together. If it is reducing, they reduce together. That is what a positive correlation means. What about negative? So negative means that as one variable increases, the other variable reduces, okay? The best example is demand and price. As the price increases, the demand reduces. So that is, they are negatively correlated. So as price increases, the demand also reduces. So that is the concept of the strength and the direction. So interpretation, we see that a positive correlation means that as one variable increases, the other also increases. It also means that as one variable decreases, the other also decreases. Basically, they move in the same direction. A negative correlation means that as one variable increases, the other decreases. As one variable decreases, the other increases. Now, a correlation of 0 indicates that there is no linear relationship. Now, what assumptions should we have in place in order to run correlation analysis? One, we need to have our variables as continuous. Please, if you don't understand what a continuous variable is, you're very welcome to attend our first lesson about data types. Then there is a linear relationship between two variables. We can measure that. The other assumption is that the data has to be approximately normally distributed. And that is something we need to check before we do correlation analysis. We need to also check that observations are independent. We check that there are no significant outliers, and the relationship is more statistic. We shall learn more of what that means. Now, we have various types of correlation analysis. The first one and the most common one, and probably the one that you are going to be doing, is the Pearson's correlation. So Pearson's correlation, of course, correlation is the same thing. The types are just different depending on the data you have and the conditions that you are doing the analysis in. So in Pearson's correlation, which other people call the Pearson's product moment correlation, it is used when both the variables are continuous and normally distributed. And it helps us to measure the linear relationship between our variables. Okay, and you can measure something like students' IQ and academic performance. Both of these are represented by continuous variables, and you can easily measure that. Now, if the data you have does not meet the assumptions of Pearson's correlation, we can try something called the Spearman rank correlation. So this one is used to measure the strength and direction of association between two variables when the data are in ranks. In most cases, when we are dealing with ordinal data, that is when we can go ahead and use the Spearman's rank correlation. Or if you have data which does not meet the assumptions of the Pearson's correlation, we can go ahead and use Spearman's correlation. So in this case, we need to have ordinal variables and we can measure them using ranks. So for instance, we can measure the relationship between the students' ranks in class and their ranks in sports performance. That is something that we can easily do with Spearman's rank correlation. There is also something called the point correlation, which we use when one variable is continuous and the other is dichotomous. So the dichotomous variable is what we also call the binary variable, especially when a variable has two categories. For instance, you have gender, where there is a male and a female, okay? So you can try to create and understand the relationship that exists between gender and the examination score. So you will see that the gender variable is a dichotomous variable. It is a binary variable, okay? And then the examination score variable is a continuous variable. So if you have a case like this, then you're going to do the point-Becerra correlation, and you're going to end up with the same exact results. And basically, that is what we are going to be doing. Now, this could be intimidating a bit when you're just starting. I'm going to take you to your actual document where we are going to put these results. And we also see how we can employ this into our statistical software such that we can come up with realistic ways in which we can correlate and understand this better. Now we want to see how you can go ahead and actually do correlation in your document. Now to do that, I'm going to start with a sample topic. And the topic we are going to use is the impact of students' academic engagement on their academic performance at Kola Secondary School. Basically, this topic is asking and wondering if students got engaged in their academia, would they actually perform better? That is the kind of investigation we want to do. Now, for us to do this, we came up with specific objectives. Objective number one is to determine the relationship between the students' study hours and academic performance. So here, our independent variable is the study hours. Number two is the relationship between the students' attendance rate and their academic performance. Our variable is the attendance rate in objective two. And then the relationship between students' assignment completion rate and their academic performance, with our independent variable being the assignment completion rate. Now, if you look at our objectives, you'll see that the three sub-variables are coming from academic engagement. For instance, the students' study hours, the attendance rate, and assignment completion are all elements of academic engagement. It is when you do these three things that we say that you are academically engaged. So that's why we want to see the effect of each of those onto the academic performance of the students. Now, as usual, if you have a topic and objectives and you want to do analysis, the first thing is to identify the type of data that you have. So we need to know what type of data do we have and to see if we can actually do correlation analysis on this data. Now, I have attached a data set, and I've also attached the data collection tool in the lesson materials. So let me just show you the data collection tool that we are working with, just briefly. So in the questionnaire, we have the demographic information, which we already dealt with in the previous lesson. So let's see how the different parameters of engagement are being measured. So we have the students' study hours. And in the student study hours, we are measuring, on average, how many hours do you study per day? So the student can tell us the number of hours that they study per day. We can also measure attendance rate by asking the total number of school days that the student attended in the last semester. So if you see, this one also has two questions. We have the total number of school days in the last semester and the number of days that the student attended. So for instance, if the semester had 100 days, we can measure how many of the 100 did our student attend. If the student attended 80 out of 100, then they have an 80% attendance rate. So we can know if there is any sort of relationship between attendance rate and their academic performance. Section D is completion rate, assignment completion. Okay, so we have two questions. We have the total number of assignments that are given to the student in the last semester. And then we also have the total number of assignments that are completed by the student. So we can know if the student received 100 assignments and maybe they only completed 80 of the assignments, we can calculate an assignment completion rate with which we can use to assume if that is going to have an impact on their academic performance. So if you look at section E is measuring academic performance, okay? And you see the question we are asking is, what was your percentage score in the last assessment examination that you sat for? You see that in many examinations, students are marked using percentages. And in most cases, the highest percentage is 100%. So we can know the mark that the student scored, and then we can compare that with the rest, because many of these can be expressed as percentages. So you see that the data that we collect here in academic performance is continuous data. The data that we collect in assignment completion is continuous data. The data that we collect in attendance rate is continuous data, and also the data that we collect in students' study hours is also continuous data. So basically, if I go up to the first page and I go to my identification of data types, you'll see that all my variables are continuously being measured. We are using continuous data. Please, if you don't understand what continuous data is, you can go back to our first lesson about data types and understand what continuous data is before you can proceed. All right, so we can have something like that. Remember, this is not going to be in your report. This is still you learning and identifying what you're going to do. So the moment you have continuous data, then we can say that this data meets the first assumption of correlation analysis, because we are saying that correlation analysis is used when we have the continuous data, both the independent and the dependent variable. All right, so let's see how your report is actually going to look like, your data analysis section. So, of course, I assume that by the time we reach here, you have already done the introduction to the chapter, you have done the response rate, you have done the reliability tests, you have done the social demographics analysis, and you have done the descriptive analysis of the variables, okay? So these ones have already been done. Please, if you have not yet attended these lessons, make sure you attend these lessons before you come to this one. So this one makes a lot of sense now that we can go ahead and do our correlation analysis. So I am going to show you how this correlation analysis is actually done, okay? So let's begin with objective number 1, which is trying to investigate the relationship between the students' study hours and their academic performance, okay? So remember we said that for you to actually go ahead and do correlation analysis, we need to make sure that our data is normally distributed, okay? The data has to be normally distributed. So what is normal distribution of data? You remember when we were talking about descriptive statistics, I was telling you about normality of data. So normality of data is data which always assumes that bell shape, okay? And it is good that we can use it to run many different tests with a lot of ease. Now, how come that in our test of normality, we are seeing this table? What does this table mean? Now, if you look at this table, it has a title called the test of normality, okay? And then there is this weird name here, the Kolmogorov-Smirnov, and then the Shapiro-Wilk, okay? If you look here, we have statistic, degrees of freedom, and the p-value or the significance value, the same thing here. Now, what does this table actually mean? If you look at this table, the table helps us understand the degree to which our data is normally distributed or not normally distributed, okay? So what does that mean? Now, I am just going to go to our data and we test normality before we can understand or before we can agree that we can do correlation on it. So this is something that we are going to first do. We are going to go to our data, but we are going to do this one at a time because this is the first independent variable or the first objective that we are looking at, okay? So we are determining the relationship between the students' study hours and their academic performance. So we both know how the study hours have been measured and the academic performance. So I have attached this data set in the lessons materials. So please, you can just open it and we follow through. So now, the first thing we want to do is to make sure that we try to check if the data is normally distributed. Now, to do that, we are going to do a little exploration of the data. So I am just going to come here to analyze, okay? So when you come to analyze, you're going to go to descriptives. When you go to descriptive statistics, you're going to go to explore, okay? So when you go to explore, let me just remove this first. When you go to explore, we first need to analyze if our data is normally distributed. So the first variable that we are talking about is this one here, the student's study hours. So we are going to get the student study hours variable, put it there. And also we are going to get the dependent variable, which is the percentage or the performance. And then we put it there in that small box of dependent list, okay? Now, when we do that, we can go ahead and say, what statistics do we want? We can have descriptives if we want, but it might not be necessary, okay? Can have it anyway. And then I can come here to plots. So when I come to plots, I need to get a normality plot, okay? You can see that we can get some normality plots with tests, and this is going to give us that data, okay? We can also generate a histogram. Histogram is here. It is that graph that is going to show us how the data actually looks like. So I can click continue, and I click OK. Now, when I do that, it is going to run. And when it runs, it is going to give me multiple tables. Most of them are descriptive. But my interest is in this table, which says the test of normality, okay? And if you look very well, this is the table that you saw the other side in the work, okay? This table here is this one. Okay? So what does this table mean? So we have two tests of normality. We have the Kolmogorov and the Shapiro-Wilk test. What you are looking for as an analyst or as a researcher is the level of significance that is given to you by the test. If the significance level is above 0.05, then it means that that data is normally distributed, okay? If it is above 0.05, then we have normal distribution of that data. So if we look at the Shapiro-Wilk test, which we look at the sig is the p-value or the significance value, you will see that we have a significance value of 0.5 for the number of hours per day. So if we have 0.584, this is way larger than 0.05. So it means that our data is normally distributed. If we had something like 0.03, then that data would not be normally distributed. The same thing happens to the percentage score. This is a dependent variable. You can see that we have 0.149. This one is still larger than 0.05. So it means that our data, according to the Shapiro-Wilk, is normally distributed. It is the same thing here with the Kolmogorov. So these are two tests of normality that help us understand if our data is normally distributed. So the rule is that you need to see what value is here. If it is above 0.05 for this and for this, then you can go ahead and do the test. Even here for this and for this, okay? But in some cases, you can have the Kolmogorov-Smirnov test showing you that they are not. But what we always want to trust is this one, the Shapiro-Wilk test, because it's the most important one, especially in academic research, okay? But that is not enough. We can also look at our data distribution and we see if it actually assumes the bell curve. So you can see it. We can just include that curve thing. You can just double click on it. And then I put this, you go to this small curve. And when you click that, you see that there is this line which shows that bell sort of curve. If it was not bell, you would see the line coming like this or like this, you know? So that means that our data is okay. So we can go ahead and do our correlation analysis on it. So this is number of hours studied, okay? So it can give us all these graphs. So this graph is for the percentage score. You can also see that it is normally distributed. Okay, you can see the bell curve coming right there, right nicely. Okay, so after confirming that our data is normal, then we can just go back. Yeah, we can just okay, just close that. Okay, so we can just go back and then we go to our document. So we are going to just describe what I've just been saying. So normality was assessed using the Shapiro-Wilk test. So both percentage score in the last assessment examination and the number of hours were normally distributed as indicated by the p-value. So I used these ones. I told you these ones are the most important ones to determine the distribution. Okay, so now that we know that our data passes the normality test, we are going to now do the actual correlation analysis. So if you look here, we already did this, and we have a correlation coefficient. This is the correlation coefficient I was telling you about. 0.040. What does this tell you? Okay, you remember, what does that tell you? So we see that the correlation coefficient of 0.04, and then we have a p-value of 0.5. So the correlation coefficient is 0.04. It is very close to zero. If you remember the number line that I showed you earlier on, the number line has zero. And we said that any value which is very close to zero, it means that there is a weak correlation. Okay? So this one means that the correlation is weak. Okay? And it is positive but weak. And also we have a p-value which is 0.5. Remember, if a p-value can only be significant if it is less than 0.05. Okay? Please don't confuse the p-value of correlation with the p-value of normality. Okay? So here we are saying a p-value of less than 0.05 it indicates that there is a significant relationship or correlation. Okay, so how do we end up with this table in the first place? So I'm going to go back to the data. I'm going to go to analyze. I'm going to go to correlate. I'm going to go to bivariate. Okay, sorry, these ones were already there. Let me remove them. And then I'm going to put in this table, I am going to put in the two variables that I want to run correlation analysis for. So here we want to do for student, for number of study hours, put in there. And I also put this was here, the number of study hours and the percentage score. Okay, this one, put it there. Okay, so if we do that, we can go ahead and choose Pearson's correlation. Pearson, okay? So even the other tests I was telling you about, like Kendall, the Spearman, they're all here. If the data was continuous or it was violating the assumption. But now we are going to do Pearson. So we say, okay. Now when we say, okay, you're going to see this table. And you're going to see this table which has, it has the number of hours and the percentage. So these are the two variables that we are running. So these variables on this side, and they're also up, okay? So you'll see that Pearson correlation, the column which has Pearson correlation indicates the correlation coefficient, okay? So you see that there is a correlation coefficient of 1 here. So it means that the number of hours and the number of hours have a perfect correlation just because they're the same thing, okay? So that makes sense. But the number of hours with the percentage score in the last assessment have a Pearson correlation coefficient of 0.04, which is a weak correlation coefficient. It means it is close to 0, okay? If it was like 0.9 and it is close to 1, then we would say it is strong. So being that it is close to 0, you will see that even its p-value is large. It is 0.5. Yet we say that it can only be significant if the p-value is less than 0.05. Okay, so what you're looking for in this table is the chi-square value. It is the correlation coefficient, which is 0.40, and the level of significance, or the p-value, which is 0.5. And this is what we have brought and put in the other table. And it is the same thing here. They have just put here, because 216 is n, which is the total number of respondents that we have. So we see we have 0.040, which is the Pearson's coefficient, with the p-value of 0.559, and the total number of respondents we had was 216. So this table is the one that I have got and copied and pasted here, this one. Only that I have reformatted it, put the variable here, and just say the number of hours studied per day correlates with academic performance to a magnitude of 0.04 with a p-value of 0.5. So in the description, I am just going to describe this. So I could say something like a Pearson's correlation analysis was conducted to determine the relationship between students' number of hours studied per day and academic performance. The results revealed a very weak, positive, and statistically non-significant relationship between the two variables. I think this makes sense right now. So the R is the correlation coefficient, the P is the p-value, okay? So this suggests that the number of hours studied per day did not significantly predict academic performance. So having understood this part, you are now in the know of how to analyze this data. So this is what we did for this variable. We did the same exact thing for the relationship between students' attendance rate, okay, still normality, and then the table. You will see that this one even had a negative correlation. The same thing was done for assignment completion, okay? Yes, and also this one had a weak correlation. So this can help you see if there is a high or strong correlation coefficient, and also if the p-value is significant or not. Thank you so much. Now you know how to do correlation. In your paper, you can try to apply this. All the materials are in the lesson of this lesson are already posted in the materials. You can download and follow through and see if you can actually apply this in your own research. Thank you.